Hi everyone. How you guys doing? Hope everyone is doing well. Been a while since I streamed. It seems that every time I get on stream, I'm like, it's been a while since I streamed. Sorry for that. Yes, hi YouTube. I am in fact live. Thank you, email for. Um, so yeah, it's been a week. Not as far as the last time, it hasn't been a month, been a week. I want to try to at least get 2 episodes or 2 lectures a week, at least. So I'll try to do that this week. Anywho, what I realized last time is I never committed my code. So what I want to do, and I kind of want to start this with committing my code. So let's do that. All right. So these are all the changes we kind of made. We just moved some scripts, and what did I do? Essentially, the only thing really I did was wrote a map loader. All right, I'll push that. All right. So now that's that out of the way. That's the first thing I want to cover. Second thing I want to cover is hi, hello, welcome to my stream. Welcome to my humble stream. Um, if you haven't subscribed yet, please by all means do me a favor. Hit like hit that like button and subscribe. God damn it, can't believe I'm saying that now. Anyways, yeah, do that please. And so I was thinking the other day that I should create a Discord server just so everyone, on Discord gets to join and ask questions and kind of say hi, and anyone needs help with their projects or just build a nice community around this whole stream. That'd be really nice, you know. So I did that. I have a Discord here. I created it. I just called it Vivi's server. That's my name, Vivi. Um, I don't know if you know. I don't think you guys know this, but Final Fantasy is one of my favorite games of all time, and Final Fantasy 9 has Vivi in it, so Vivi. Woo. Um, yeah, I don't know what I'm gonna call the server, or I end up calling the server, but for now it's Vivi. I will link the server link in every single video from start to end, so you guys can kind of join and check it out. So now that is out of the way. Cool. We should continue moving on with the code and kind of finish this up. All right. So what did we do last time? Well, we started working on parsing a file, right? We wrote. Let me zoom out a little bit here. We started parsing out a file on map loader, and we essentially said that, hey, let me go ahead and file or check out what the file is. So it's in assets maps. So here's the file. I can delete this. So this is the file essentially. We can identify the file by the first tag. So we know this is a map, and then we kind of parse this tile sheet, and then we get the equal sign and figure out where this tile sheet is equal to. And so we're essentially trying to do that. What I want to do is today is kind of finish up parsing this file, map file, and kind of start loading the map into our game, which would be really cool. And so all I'm doing is I'm checking if the file is not valid, and initially it is not valid, right? I'm opening the file, I'm looping through the file line by line, I'm checking if it's not valid, which it is not valid, and then I check the tag. If the first line is equal to this tag, which it is currently, so here, right, that's the first line, so it is equal to that tag, then I say, hey, the file is valid, then I should continue with my code. So continuing with my code, going here, check if it's valid. Yes, it is valid because I made it valid. And I start parsing stuff. And so we talked about this last time. We talked about the find function and how, I can split the string, right, by this equal sign, or or not split, sorry. I can look for this equal sign. I can find out which index this equal sign is at, right? And we know this is at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It is currently at index 9, right? So I find that put it in count, and we talked about subster. Subster basically cuts the string. So essentially, all I'm saying is I would like to cut the string from the start until that index, and I save it in this variable. And then the value is I also substring from where I left off until the end of the string, right? And I kind of went over that and I covered that. And so if I go and kind of play this program, start this program, print the variable and the value, you'll see that the variable essentially should be tile sheet and the value should be this entire string. And so I'm gonna verify that real quickly and just make sure it is actually that. And I did not go completely insane. It is. So my variable is tile sheet, and my value is this is the entire value, right? And this is awesome. So we kind of did that the first initial thing, right? And so I keep want to do that. I keep want to doing that. Sorry, I want to keep doing that for every single line, right? And so what I can do is I would like to do that for every single line. Now I'm breaking here, so essentially if I remove the break, that should do it for every single line. So if I press play, yeah. So this parses the entire kind of, I'm just gonna remove the whole yeah, I'm just gonna part, make it a little bit clearer. Right, and so essentially what this is gonna do is just parse out my entire tile sheet. It's gonna say this. It's gonna take tile sheet and the value. Right, this is line 2, and then line 3, it's name and level 1. Line 4, style width and 16. Line 5, it's style height and 16. Line 6 is scale x and 5, and scale x and y. And then finally, data. Then there's a space, obviously, over here. And then data, and then my actual data, right? So I essentially parsed the entire file, which is absolutely awesome. I love that. That's super great, right? All right. So now that we've actually done that, and that all works and nice, dandy, as they say, what I want to do is kind of create the structure of this file, right? So what I'm gonna do here, I don't know if I'm gonna keep it here. I'm probably gonna move it. I'm gonna probably put it in a, yeah, I'm gonna put it in a header file. So what I'm gonna do, but just for simplicity's sake, I'll keep it here for now. I'm gonna create a struct, right? And we talked about structs and classes. We said that structs are no different from classes. They're essentially the same. The only difference is by default. A struct has an access level public by default. So all functions are public by default. Where a class, all functions and variables are private by default. Struct functions and variables are public by default. So right now this is private by default. Where in a struct, so I'm going to call this map, I'm going to call it map data, right? Where by default, if I put this line of code in here, by default this is public, where by default this is private, unless you actually specify specify differently, where I'm specifying this public differently, right? Essentially that's the only difference. You can inherit from, you can do inheritance, you can do everything you can do with a class. A struct can do everything a class can do, right? We talked about this so many times, so I'm gonna repeat it again. All right, so the reason I picked a struct is because in C++, we have well, I wouldn't say a tradition, but essentially it's how to explain this? It's kind of understood amongst programmers that a struct is plain data, plain old data, plain old data structure. Basically, what that means is you should only put data in here, no objects, no classes, sorry, no functions. So only data, only variables, right? And that's why structs exist. Well, yeah. And so I'm gonna do that. So what is the data that I need? Well, all this data. I need all this data here over here. Right? I mean, there's no difference. I could have made it class. Zero difference. Just a struct is known to be plain old data, which is data only. Alright, so I have my tile sheet. My tile sheet is gonna have a string. Right, so I know that's a string. What else? I have my name. My name is also going to be a string, so that's std string. What else do I have? I have a tile width. So this is gonna be tile width. which is going to be an integer, an unsigned int, unsigned int. Should I make it an unsigned int or just a regular int? Because if someone by mistake does a -1, that'd be really annoying. I mean, they shouldn't be negative values, right? Unsigned int is fine, I think. I think that might bite me in the ass later on. And the reason I say it might bite me in the ass later on is because if simply someone makes this equal to -1, this will wrap around to its biggest value. And so if you don't know what unsigned integers are, for whatever reason, right? So let's go here real quick. Can we talk about integers and floats and all these data types? An unsigned integer basically means that this integer or this variable can only hold positive value. It cannot have any negative values at all, right? And so you can think of this way. I have my variable over here, and it starts at 0, right? An unsigned integer starts at 0 and goes forward. So you have an int, a regular int, right? A regular int has a range between -2.1 billion, that it can hold this number until or up to positive 2.1 billion, right? That's a regular integer. However, a uint or an unsigned integer can hold values between 0 and 4.2 billion. And notice those negative values now moved to the positive side, right? And so that's essentially what happened. And so this is we start from 0 and we go up to that. So the question now is, what happens if I say, hey, this is equal to -1? What if I have a variable, a uint variable or an unsigned integer variable, let's call it HP, and I say HP is equal to -1? What happens in this case? Well, in this case, you can think of it as this, or you can imagine it as this. We are sitting in a loop. So this is a 0, right? And I go all the way a circle up until 4.2 billion, right? That's the biggest number. And so you can see here there's 1, 2, 3, 4, 5, 100, right? 1000. And I keep going in the circle, going all the way. The numbers increase all the way until 4.2 billion, right? So if I try to do -1, right, that means I'm going essentially back, right? Because I'm here, I am at 0. If I say equal to -1, I go back. And so how far I go back is dependent on how much this number is. So -1 would be 4.2 billion, around that, right? If I say this is -1 billion, right, I go in this direction by 1 billion. So the value would be 3.2 billion, right? Because I went -1 billion in the opposite direction and I cannot have a negative value. Now I am at like 3.2 billion. If I go -2 billion, I go all the way to 2.1 billion, right? And so on and so forth, or 2.2 billion, right? And so that's what happens if you try to give a negative value to an unsigned integer, right? And so just to prove this real quickly, and just to make sure this actually is correct, and I'm not saying nonsense, because sometimes I do, because, well, sometimes that happens. So what I'm gonna do with this entire main function, I'm just gonna comment everything here just to, just test this out real quick. All right. So what I'm gonna do here, I'm gonna do unsigned int a equal to minus. Well, I need to do. Let's do -1 first, and then unsigned b to -1 billion. So this is 1, 2, 5, 6, 7, 8. $100 million. I think a billion has this many. So this is supposed to show me, or this is supposed to show me um, you know. This is supposed to show me uh, the values. Uh, this is supposed to show me 3.2 billion, right? Positive 3.2, and this is supposed to show me around 4 point something billion, 4.2 billion, something like that. So hopefully this is correct, and I'm not actually. All right, so this just showed 4. So the first value is 4. And the second value is 3.2 billion. So here it is 3.2 billion. You saw that, right? So I'm not wrong, right? It did say 3.2 billion. But why did this show 4? Oh, no, hold on. I messed up. Okay, it's the console thing. Yeah, there you go. I was confused. Okay, so what happened? Let me explain what happened there. What happened there is I pressed play and I kind of clicked. Whenever you click on the console like this and you see this white kind of rectangle, that means the application has paused execution. And so if I want to continue execution, I right click with my mouse. And so because I kind of paused in an awkward situation, some of those numbers were printed here, the others were printed there, and it was just a whole awkward thing. And so here you go. So I'm printing the variable a, and you can see it's 4.2 billion, right? It's if I go here and I say inside int equal int dot, or where is it? Int or sorry, int max. Actually, it's uint max. Uint max. Uint max. Right. So this is a macro, right? And we talked about macros very briefly. We actually defined one, I believe, in here. We deleted it. We'll talk about macros a lot more later on. Essentially, this is just a macro for the preprocessor. And so when the preprocessor sees this word, it will replace it with the value of this. This is a hexadecimal value, and it'll just replace it with this value. That's what the macro is, essentially. And you can define a macro really easily just by doing, like, fine, we did this before. Find map to 1. So anytime the preprocessor sees the word map, it's gonna delete map and replace it with 1. So what I can do here is I can say, hey, int HP equal to map. And so what that means is the preprocessor will scan my application, and when it sees map, it's gonna replace it with 1. And so this is HP is now equal to 1. And so this is the same thing. This is a macro in C++. Where it's uint max, u for unsigned integer max. This is the maximum unsigned integer value. And so what this does is essentially replaces this word with the maximum value of a, right? And this is going to be called q, and I'm going to print q. And so what I'm trying to prove to you here is that q will have like 4.2 billion, and this will also have 4.2 billion, but this will be off by one number, right? Because we're doing -1. Right, and so I'll show you this in a second. And so, oh, look at that. Never mind. I was completely wrong. It wasn't off by one number. It was exactly the same number. All right, that's interesting. So if I do -2, that will be off by one number. Yeah, so you can see how max is at 5 and 2 is I'm off by one number. That's actually kind of interesting, right? And so when I reduce by -1 billion, I go back to 3.2 billion, which is kind of cool. But anyways, right? I proved that to you. I have officially proven myself to be a worthy explaining. What was the topic at hand? Oh, right, we were building the whole data structure over here. And so this is why I'm saying, hey, it might bite me in the ass later on, because if someone says -1, it's going to go to 4.2 billion, and you're going to be like, why is it at 4.2 billion? This makes no sense. It's supposed to be -1, and you're like, and you debug for like an hour or so, and you're like, oh, it's an unsigned int, you fucking idiot. Why would you do that? Just put it at a normal integer. What kind of shitty program are you? Right? I went through that phase in my life. That happened, right? So I don't know if I should keep it unsigned or not. I will keep it for now just because it is not supposed to go negative values into a negative value. But both of them going either negative values or positive values will be a disaster number, disasters. Not positive value. If this goes to 4.2 billion, the value here, that'll be really bad. Or if it goes in -1 because it's an integer, that'll also be bad. So in both cases, it will be bad. So whatever, I'll just make it unsigned int. And I remember I was reading somewhere on the internet, and someone said never make anything unsigned int unless you need the extra space. And so I don't need the extra space, so I think I'll just keep it integer. All right, I'll just make it easy for myself. I'll just make it integer because it's easier to debug this way. Even if this value is never supposed to be a negative value, you just kind of protect yourself. Be like, okay, it's easier for me to debug this and understand what the fuck is going on in here. Right? Sorry for the swear words. I'm in a mood. Anyways, these values obviously will be 0, and I'll initialize them to 0 in the constructor. Do I need the constructor? No, I'm just gonna write extra code for no fucking reason. Just put 0 here. 0, 0, 0. That should be equal to. Right. I'll just initialize them. This data is gonna be an array, right? So the question is how big this array is. Well, what I need to do here is I need to write that here, right? So I need the variable here that says data size, and my data size is 1 element, 2 elements, 3 elements, 4 elements, 5 elements, 6 elements. So this will be 6. This will be 6 elements. All right, cool. So 6 elements over here, and so I can figure out how big this array should be, right? And it's not going to be an array in my case because could be an array. I can make an array pointer, which I'm going to do, I think. Yeah, it's going to be an integer pointer called data, right? And I need to figure out how big my data is. So this is going to be int data length, something like that. It's going to be 0. And this is going to be equal to null ptr, which is null pointer. I call it null pointer, but it's null pointer. I'm just cool. All right, so I have my map data structure, or my map data, which is going to hold all this data, which is awesome, right? All right, so let's do that. Let's. I mean, I'm gonna move this to a file. I mean, I could do that right now, literally. So I'm just gonna make a new header file called map data, right? Come on, Visual Studio. Visual Studio, you were compiled into 64-bit. You are supposed to be. Your Visual Studio. This is Visual Studio 2022, so it's supposed to be faster. So what the fuck is taking you so long to open? Come on, man. Just want you to create a file, not magic. Again, apologies. I'm in a kind of mood. Anywho, I'm gonna include string. Alright, and there you go. This is my header file, which is my map data, which is gonna contain all data for my map. Right? I'm gonna clean this up. Maybe I think this is nice and clean, right? Split those two, then those two, and then those two. I think this is cleaner than this. This is a little bit, yeah, that's a little bit cleaner. Yeah. Yay. Yay. Absolutely. Alright, cool. So that's done. So I can delete it from here, which I did. And I can, now all I have to do here. I really need to get a new mouse. This mouse wheel is garbage. Don't buy Razer mice. I mean, Razer is great and all. They're fucking terrible. Horrible mouse. Anyway, going back to Star War, Xbox versus PlayStation, Razer versus, I don't know. Who else manufacture mices? Anyways, moving on. What do I want to do here? Map loader? No, map data. Map data. Yep. Map data. Oh. Map data. So I don't know if I explained this. The double quotes is if you're including a file in your project. These kind of pointy brackets. This is a file outside your project. No idea if I explained. But there you go. Explained again. Deal with it. I'm explaining things twice. Why not? And so what I want to do here, I want to essentially create an object of map data and call data. Right? This is not. I mean, this is just temporary. You know, it's not gonna end up looking like this. But again, just baby steps, as I like to say. Baby steps are the steps. All right. So data dot. Let's start with tile sheet equal to this. I copy this a bunch of times. I'm going to go ahead and copy all this. Paste. Oh my god, my mouse is horrible. Guys, help! Someone buy me a mouse. Kidding, don't fucking buy me a mouse. I can afford a mouse, okay? I don't need. Wow, that's kind of aggressive. I'm bloody. It's a link. I'm not crazy, I promise. Nintendo, I don't want to buy anything. Can you stop emailing me? Thank you very much. Really, I should just close my email. Much easier. There you go. Alright, solve the issue. Don't need this. Alright, cool. So these should be 0, 0, and this is memory address for something. I'm just gonna call it null for now. 0 and 0. Alright, so and this is kind of the ugly part, right? This is where this is gonna look a little bit ugly, but yeah, it's not great, but it's whatever, right? We're parsing a file. This is what I have to do. So what I need to do now is essentially say this: if file equal oh, JavaScript. I was programming JavaScript today, so 3 equals, because why not? Python is 4 equals. I'm kidding. Python doesn't have 4 equals. Python. Just kidding. If variable equal to tile, what was the tile map, right? It's all small letters. Nice. Okay. So if it is equal to tile map, then I would like to do the tile map parsing. Or I just essentially want to do this. This is equal to value, right? And so what I can do is I can put this in a switch statement rather than if like this. So I haven't talked about switch statements. Switch statement is essentially, they're really cool. That's essentially what they are. They're very cool. And so I'll show you the difference between those two if I haven't. And I doubt I did. So let me just type this in an if statement first and kind of show you what the difference is. And I'm 99.9999% sure this code will actually not work, because C++ is great language. That was sarcasm, by the way. Sarcasm. I don't know if you've noticed, but yeah. I haven't programmed C++ in quite a while, so not that big of a while. 6 years? I'm kidding. Not 6 years. 7 years. So I'm pretty sure this code will not actually function. I'm gonna show you 2 ways of doing this: the good way, the bad way, the way you should do it, and the way you should definitely not fucking do it. And even if you do it that way, I'm gonna hit you in the fucking face. Sorry, I'm aggressive. Anywho, move this over here, take this over there, put this over here, put it there, put this there. I need music in my stream. Yeah, the problem is I could put music, but some people don't like music, as in like while studying, and that might be an issue, right? So I'm gonna put it this way, it's a little bit more clear. And the reason that's an issue is because, right? So some people don't like music because they want to focus on studying, and other people, well, there's no other people. Some people like it, some people don't. But the main issue is I could get copyrighted. Welcome. Anyway, so this is one of the ways you could do this, right? And essentially, this is the same code over and over and over. It's literally duplicated 100 times, which is not ideal. I'll have you know, not ideal at all, right? And I don't think you can do value here. I have to do. Oh shit! How do you parse an integer in C++? Int dot parse? No, that's C sharp. Parse? No. I believe is std s2i s2 int. So this is string to int. So string to int, right? Because C++ fucking garbage. Anyways, love C++. C++ the greatest language in the world, guys. Come on, stop saying C++ garbage. It's not garbage. It's really good. Love C++. Fuck C. Okay, anyways, right? And so this is one of the ways you could do this, right? You have a bunch of if statement, if else, else, right? And essentially it will check for the ifs. If it's not this, it will check the other one. If it's not this, it will check the other one. If not this, it will check the other one. If it is this, it'll execute this code and not bother checking any of these, right? And so that's what an if with a bunch of else if behind them, right? So eventually it'll check from the top to the bottom. If it reaches one of them, it will not bother checking the rest, right? So that's kind of important. You could do that, or you could do it in a switch statement. Switch statement is a little bit cleaner, a little bit nicer, just a tad, right? And it looks something like this. And both codes do exactly the same way, the same thing. They're just a little bit different, right? So what I could do here, I could do case break. What's your problem, bro? Bro, what's your problem? You gonna fight? I'll fight you. Expression must have an integral or an enum. You can't switch a string in C++? Hold the fucking phone. I need you to hold the phone. Bing, I need you to get the fuck out of my way and take me to Google. Thank you. Reason why has to do with, okay, so the question is why the switch statement cannot be applied on strings in C++, I assume. Yeah, C++ code looks like C++. Yeah, it is C++. Is it C++? I mean, it looks like C++, but doesn't say anywhere that's C++. How does anyone know this is C++? I mean, they could look at the code and be like, hey, this is C++. But sure, C++. Okay, the reason why has to do with the type system. C++ doesn't really support string as a type. It does not support the idea of constant char. Yeah, shut the fuck up. In order to generate the code for switch statement to compile, must understand that it means for two variables. For items like ints and enums, this is trivial bit comparison. But how should the compiler compare two strings values? Case sensitive, in case sensitive, blah, 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 blah. Okay, whatever. Additionally, C++ switch statements are typically generated as a branch table. It's not nearly as easy to generate a branch table for a string style switch. What the fuck is a branch table? You know what? I don't give a fuck. So, hey. Thank you. Really appreciate your support, Mr. Brainer. Yeah. Thanks. You want to learn C++? This is C++. I'm doing C++. C++ is great, by the way. I don't know if C++ is great. Thanks. Rainer, could you go and fix my game, please? So, for those who don't know, Rainer is my lovely you know, uh, coworker. He's a fantastic fella. I recommend him 10 out of 10. By the way, he is the greatest, absolutely the greatest, top notch. He's like his 5 Michelin star kind of guy, top notch. But could you stop watching the stream? And go fucking fix my game. Thank you very much. All right, cool. So switch statements don't work in C++. Who fucking knew? Not me. Anyways, so yeah, this will do. Bunch of if statements. But the only thing that I will change is nothing. We'll have to do with this. Anyways, so now that this is done, right, and we have this is kind of this ugly fucking if statement that we have and exist here. What I can do next, is what am I gonna do next? Well, test if this actually works. So what I'm gonna do is, I'm just gonna STDC out all these lovely people. So just copy all this. I'll paste it all again over here, and delete, 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 delete. Oh, great stuff. Can you appreciate you and being the productive member of our society? Very much, thank you. Really appreciate you. All right, look at this magic. Look, ooh, ooh, crazy. How did he do that? I don't know, crazy. Um, and then, well, oh, I can do this, but it's extra, a little bit of extra work. Do this, and then, ooh, ooh, crazy. How did he do that? I don't know, but he did it. Oh my god. Okay, I'm gonna stop. I'm sorry. Anyways, so in theory, if I press play now, it should print all this shit. Right? And apparently it's printing it a million times. And not correct at all. Not correctly at all. Well, it's kinda is correct. Kinda is and kinda is not. Why the fuck is it? Oh, okay, I should print it at the very end. Outside this loop. Hold on, where's this loop? Loop and follow the line, kids. And over here. Just print it once, please. Thank you. Does it work? Absolutely fucking not. Why? When is this gonna work? Oh, I forgot, guys. Because remember when I told you, I'm pretty sure 99.9999% sure this is not gonna work. Yeah, well, this is not gonna fucking work because C++, right? Because C++, this will never trigger, right? I put a breakpoint is, and you. Oh, this actually triggered. Never mind. Who thought I'm a dumbass? Crazy world we're living in these days. I'm telling you, it's wild, wild out there. Very wild. Oh, but the rest did. Oh, because why didn't the rest trigger? Oh, because it's named differently. Maybe I should just do it like this, just to be consistent. I think just to be consistent. Yeah, that's what I would. Never mind, this code did work, and I'm just an idiot. Who'd have thought? Crazy world we're living in. But anyways, if you see here, look, so we printed the tile sheet right here, and then we printed the name. We printed the 1616, 5 and 5, and then 0 for the size or data length, and then a bunch of zeros for the memory address because that's a null pointer, right? Is it called data length or data size? I'm gonna call data length. There you go. That should print 6 now, which it did. You can see here, 6. I promise. I'm not lying. Right, we parsed the file, ladies and gentlemen. Look at us. Uh, so crazy world we're living in, right? This worked. And we parsed the file essentially. That's it. That's all. This bit of code, all we needed really to parse the file. Now, here's the problem. If someone, right, anyone goes ahead and I don't know, puts a P over here, this application will crash or my parsing will crash, as you can see here. And the reason this crashed is because I take the whatever is in here and I try to convert it to an integer. And as you know, I don't know when was the last time you took a math class, but p is not part of the numbers that we use on day-to-day basis, right? It's, you can't go 0, 1, 2, p, 5, 6, 7, and so on and so forth. And so it's gonna try to parse the p into a number and be like, I don't know what the fuck am I gonna do, so I'm just gonna crash. Which is, how am I still getting emails? Can you? Thank you. Okay. All right. I understand. I understand. Thank you. Right. So it tries to parse p and p doesn't make sense. It can't parse it. Right. So we can kind of fix this and we can make sure that this is an integer before we parse it to an integer. And the way we do that is by, I actually don't know. So we're gonna leave it the way it is. There are many problems with this code. Especially if someone, I don't know, removes the equal sign, this is gonna crash again. Or, oh, it didn't crash. All right, well that's surprising. I guess just the p thing. But what else can we do? What else can we mess up if I delete those two lines? Does it just, yeah, okay, well, that's versatile. Yeah, it's just the p thing. Well, we need to figure out how to make sure something is a number. I can put this in a try catch rather than my application crashing. All right, so I can teach you try catch, which is kind of cool. I can do this this thing called try and catch. It's kind of crazy, right? Because you try something and if it doesn't work, you catch it. Just like how you catch a ball, like flying through the air. Have you ever felt like a plastic bag flying through the air? Something along these lines. I don't fucking. But anyways, what happens here? There's this concept in C++ or in modern languages, and a lot of C++ programmers seems to hate this for whatever fucking reason. But why the fuck not? Where you try something, and if it fails, you catch it. So rather than your application crashing, actually catch it in here and print a message like, hey, you fucked up because you're an idiot, right? So I can do that. stdc out. I don't know. Life happened. Alright, that's a valid error message, right? We don't know what the fuck we're doing. Let's put that lovely p here because 1, 2p, 4, 5, 6. 1, 2p, 4, 5, 6. Right, so hey, I don't know. Life happened, right? I got an error. My application didn't crash, which is lovely. It's fantastic. Top notch. 5-star Michelin something. I don't fucking know. But, it didn't crash. That's good. It's good. That's lovely. So I can try catch it. But that doesn't, fix anything. You just make sure that our application doesn't crash. Which is, not gonna lie, it's nice. So what I can do is I can just try catch the entire thing. I can kind of try catch the whole thing, right? Which is kind of nice, as they say, it's lovely. It's lovely. But anyhow, right? This works, right? I'm reading my data from a file, and I'm storing them in my data structure, which is lovely, lovely, lovely stuff. Very, very lovely. Let's actually put a proper message here. I don't know. Something went wrong while reading file, and we could put the file name because we are crazy like that. We're gonna expose the file name. We're gonna be like, hey, I'm gonna snitch on you. Something went wrong while reading file assets maps level.rm map, right? Which is interesting. These things are very interesting. Very interesting. Fucking hate my mouse, but someone donate $5, please, and buy a mouse. Thank you very much. So done with that. I can remove all these because I know. Well, I can't remove them because we still are not reading our data, right? So we're reading everything except our data. So now we gotta work with our data, right? So essentially same thing, right? It's the same concept, except I believe I can fly. I can. Okay, I can do this. What I can do, is there a split function here? I don't know. Maybe there is. So line dot split. There's only substr, right? Swap, reverse, shrink, insert, find first, erase, register, assign. Yeah, that's the loveliest language of all time. It was made in 19. Sorry. It was made in 1422, the year of the rabbit. Yeah. All right. So what the fuck am I gonna do? I need to parse this, right? I need to parse this data, right? And I know where this data is. It's the value, right? So I can do value dot subster. I can put this in a for loop, so I can say, hey yo, bro, hey lovely, excuse me, sir, good sir, good gentleman, excuse me, good sir, you know. I could do this, and then I could go like this, and then I could call this v, because we, and then I can do I don't want it until the end of the line. Yeah, this. I can go like this. I can std see out v, because we. I'm so sorry, guys. I'm in a mood today. You're gonna have to take the bullshit. Um. Oh yeah, here it's. Mm, mm. No, that's not supposed to. That's not what was supposed to be printed. So what I can do, I can say std out over here, master. Let's fucking do this over here, over here, master. Fucking hell. V. V. What the fuck am I? Oh, I'm doing line. What am I doing with my entire existence? It's value. Guys, I'm stupid. I'm sorry. Oh, here, see, one. Over here, mister. And I heard it 120, right? Which is the first number over here, which is 120. Now I want the 121. Woohoo! How am I gonna do that? Ah, crazy world we're living in. I don't know. Well, here's the thing. I got the 120, right, from zero, from index zero, which is, okay, this is over here. Imagine this is a new line. This is index zero. I said cut from zero until the comma, which is here. Right? Cut from zero until the comma, and the comma is over here. Right. And now what I can say is, hey, I know where the comma index, so cut from here until the next comma, and then cut from here until the next comma, and then cut from here until the next comma, and then cut from here from the next comma, and then cut from here until the next comma. You guys didn't think I was gonna do the whole thing, but I did, and I would have, even if it was this big, because I am that fucking bored. Actually, I'm not bored, I'm just in a mood. But anyways, going back to this. Why did I press play? Yeah, let me show you how to get the second comma, right? And essentially the second comma is really easy to get. Remember when we said here I can do count 2, or I can just say count, right? I can override this variable. I can say count. Oh no, I do need this variable. Okay, I'm just gonna do count 2, because why not 2? If I put a comma here, right? The next argument in my find function is an offset of, an offset of where do I want to start searching from, right? And essentially the offset is 0 at the very start. So if it's 0 and I search for the first comma, it's over here. However, if I say I want an offset of 4, then 1, 2, 3, or sorry, 0, 1, 2, 3, 4. So I start searching from over here. Right, so this is the offset. So if I search from over here until the next comma, and the next comma is over here, right? And then if I put an offset of 4, and then yeah, cool, fantastic. All right, so I'm just gonna put a 4, hard code it, because I can hard code things, because you're not the boss of me. You're not the boss of me. Oh, Malcolm in the Middle. I fucking love that show. Anyways, so I'm gonna say, hey, cut from count until count 2. Woohoo! Crazy. And so let me explain this. I'm just gonna put the over here master at the very top. I'm gonna print v over here, and then I'm gonna print v over here again. All right, so let me explain what's going on here. Right. So I'm basically saying, hey, yo, bro, how are yo? I would like to find the first comma from index 0. And the first comma from index 0 is this, right? So 0, 1, 2, 3, right? And so I want to start cutting from here until the first comma. So I get the 120, and then I print the 120, and it's fantastic. And life is good and great and lovely and all that jazz, pizzazz thing is happening, right? Cool. All right, next. Now I want to. If I repeat the same line, it's gonna also give me this comma, which is I don't want this comma. I want this comma. So what I can do is I can say the following. Can I put a comment here? Thank you very much. I want to say the following. Hey, find the character comma with an offset of 4, meaning ignore the first 4 characters. Jump the first 4 characters. So we're gonna do 0, 1, 2, 3, 4. Woohoo! And then I am here. Right? I'm over here. Cool. Cool. I'm going to find the first comma from this position, and the first comma from this position is this comma. Crazy world. And so I'm going to get the index of the second comma, which is this comma over here, right? And so I'm going to say the following. I'm going to say, hey, I would like you to cut from count. Where the fuck is count? Well, if you remember, count was this comma, right? Because this is count over here. This is where the comma is. So I'm going to start cutting from here until here. So I'm gonna cut this whole thing, which is crazy world, crazy talk. It's crazy, guys. It's crazy, right? And so if I press play and I look at this over here, mister, you can see that it did not print anything. That's fucking lovely, isn't it? Why did it not print anything? That is the question that I currently have in my mind. That is truly the only question that I have in my mind of why didn't it thing. It did print over here, mister. It didn't print the V or the other V. Why did it not print the V? Ooh, it says something wrong. Okay, so it crashed. Oh. Why did it crash? Okay, so fantastic. All right, something is wrong with my application. I don't know what it is, right? And it's not crashing because I have this try catch. So essentially, if I just ignore this try catch and I tell this try catch to fuck off, my application would crash, which it did, right? Fantastic. But that doesn't help. I still don't know what the fuck is wrong, right? And you might go here and be like, okay, I am now in a new file called string in the holy, I don't fucking know, in the middle of the desert. I don't know what the fuck is going on. I don't have water. There's a snake in front of me, and there's a jeep plowing behind me. Is plowing the right word? Let's say it is. Going, 100 miles an hour. Hey, we're not in the United States. 100 kilometers an hour, right? And it's gonna crash into me. So snake in front of me, jeep behind me. What am I gonna do, right? And that's the metaphor where we currently are in the script. We're fucked essentially, right? And so looking at the script, and I'm like, what am I gonna do? What is going on? What do I do? I don't know where I am. Well, you see, I'm gonna tell you a really, really cool secret. Are you ready? There's something called the call stack. I'm just gonna back up here. I'm sorry for the I just got intimate with the microphone a little bit and yeah. And so what I'm gonna do here, there's something called the call stack, and if you don't have the call stack, fear not, sir, good sir, fear not. Do not be afraid. For I will rescue you. What you can do is go to the view menu, or click on the, you see the word view here? There's a view word here over top, at the very top left, of the very top, very top left. There's a view word. You click on the view word, and a menu drops down. No, crazy. Yeah, this is the wrong place. It's in debug. All right, so you go to debug, right? Crazy world, right? You go to debug. You click on window, and in window there's a bunch information window thingy. There's this call stack here. You click on the call stack. Oh, crazy world! I'm in the call stack. And if you remember, we talked about the stack, and we said the stack is a part of the memory where we store variables, right? And we store our function calls, or we kind of, figure out, we store variables, and we store which function we jumped to. And I don't know if I explained that part. I know for a fact that I explained the stack, and I don't know if I explained the stack pointer. So either way, I'm gonna do it again. And if I did explain this before, I apologize. I'm re-explaining it. Seems like I keep re-explaining things, but fear not. It's good, just to review stuff. Put stuff in your brain. All right, lovely ladies and gentlemen, we have something called the stack pointer. The stack. That seemed like a weird K. There you go. Stack. Oh, excuse me. Pointer. Now, the stack pointer is a lovely pointer. It's the best pointer. It's the most fantastic pointer that ever existed in the entire world. Let's say you're in a function called int main. And this is a function which is a fantastic function. It's the best function in the world. And in this function, you called another function. This other function is called, I'm going to use colors, guys. Crazy. Add two numbers. And you're in this function. This function is fantastic. It's the best function in the world. You love this function. If it wasn't for this function, you wouldn't be born. Essentially, that is what is happening right now, right? And so this is the function. It's over here. It's called add two. I'm not gonna fucking write it again. Okay, add two numbers, right? Then you open brackets. Oh, crazy, lovely, lovely, lovely. Right? You're in this function. And you know what the craziest part is? This function calls another function. Oh no, this is called add three numbers. I'm gonna fucking write it again. So it's called add three numbers, and this function is over here. It's called add three, right, numbers, and it's over here. And then it does whatever, right? Now the question is the very, very difficult, very pressing question. It's very pressing. It's as pressing as it can press. How do we know how this program will go? It will go to the main function, and then it will jump into the add to number function, and then it's going to go to here, and then it's going to go here, and then it's going to jump here. It's going to execute everything here. How does it know that it's supposed to go, whether it should go back to the main function, or whether it should go back to this function? Crazy. I don't know. Crazy world. Well, you want to thank the stack pointer. Oh, yes. The stack pointer is one of the best pointers out there. It is prime A pointer. It is top-notch pointer. So this is the stack. This is the lovely stack. Every time you push some, hello, Mr. Alvin. Welcome to the club. I haven't talked to you or I haven't spoken to you or seen you in a billion years. But hi, welcome. Welcome to the stream. Anyways, so this is the stack, right? And the stack says when you jump into a function, you put the function over here. So we put main because we went into main, and then we go to the next function, which is add two numbers. We push that function right here, add two numbers, right? And then oh, let's put colors, guys. We have colors. Come on, we need to use colors, please. I'm sorry, guys. I'm sorry. Add two numbers. And we're gonna delete this. We're gonna put this over here. We're gonna do main. Lovely. All right. So I go into main, and then add two numbers, and then we go to another function called add three numbers, where we can add three numbers. Crazy, crazy world. All right. Cool. So how the fuck do we know? How the fuck are we supposed to know that if we go to main, and then we jump to add two numbers, and then when we jump to add two numbers, we jump to add three numbers, and when we jump to add three numbers, we execute code, and we finish executing code. How the fuck are we supposed to know whether we should go back to add two numbers or we should go back to the main function? Well, again, like stack pointer. And so the stack pointer moves every time you add something. So I did main, it moved, and then added two numbers, it moved up here, and then finally it moved up here. And so you are now here, right? And so now you're currently here, you're executing this function, you're done executing this function, you reach the end of the scope, right? This is the end of the scope. So what happens now, you pop this out of stack. Popping it means it goes out, it goes out, it goes bye-bye. And then the stack pointer goes down. And then now we know that we're supposed to go back to this function because the stack pointer went down and under it is this function. And now that we're done, we reach the end of this scope, it pops. It goes a bye-bye and it goes over here and then crazy. And then we go over here, we go to the main function. And the main function, we continue executing our code, right? And so that's the stack pointer. It's a lovely pointer. It's the best pointer. It's one of the greatest pointer in existence. Guys, I'm in a mood. I'm sorry. So this is the fucking call stack we're talking about, right? This is the stack pointer. The stack pointer is sitting over here, and you can see this lovely yellow arrow. It's the greatest arrow of all time, right? Times. And so it's sitting over here, and everything that's grayed out, essentially you can't visit, right? Or if you try to visit, it's gonna say blah 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 blah, can do not load, blah blah blah. Alright, so what you could do is visit the white stuff. And so if I double click here, I go to like the error over here. It crashed over here. Glory, crazy world, we're here. Hallelujah. Something, I don't fucking know how the song goes. But then you remember that you're a fucking idiot and you did not return this to a normal number. And see, guys, this is why you need a brain, right? Because 1 2p 4 5 6. All right, so now I know why it fucking crashed, right? Because I went through the stack, right, line by line, or I kind of went over here and be like, oh, this is not my code. I went here, oh, this is my code, and it crashed again. See, it's after I fixed this problem, it crashed again. It crashed on the slide. Crazy. I don't know how. So okay. Alright, so it crashed over here, right? And so now I know there's an issue on this line. Cool, right? And the call stack is really important. It's really, really useful debugging tool. Lovely. So now we need to figure out why the fuck is it crashing over here. So this is count. Oh, count is -1. Why the IB? Why the IB -1? Why doing the crashing? Why doing the crashing, sir? Oh, because yeah, this is supposed to be over here. So oh, look at that, crazy! We're living in a crazy world. All right, that worked. So hi over here, mister. All right, so it's over here, right? We go over here. And then we got the 120, like I said we would, right? This is the first V. Right? It printed the 120, and then the second V, it printed this. This is where it printed, right? So it's not completely correct, right? But we will fix it. Guys, have no fear. Dear, have no fear. So rather than rather than hard coding the 4, what I can do is just say, hey, how many characters I should skip, right? We talked about this, the offset. How many characters I should offset is by the count, because here's the thing. Again, oh well, it's over here. Here's the thing. I found this at index 4, right? So 0, 1, 2, 3. Well, it's at index 3, right? I know I'm here, okay? And so what I can do, I can say start, rather than hard coding the 4, I can just put count over here, right? And that will give me the index, but I can do count. I have to do count plus 1. If you don't do count plus 1, because count is this index, count plus 1 is this index, right? So if you do count, it's still going to give you the same number. This v is going to print another 120, because this is like you are here and you're telling it, hey, find the first comma. So you find the same index, which is, crazy world, right? Let me restart. Wait. And so it's gonna print 120, and then, well, didn't expect it to print that, but it's wrong, right? So, okay, hold on. Okay, so now I'm gonna show you the other kind of, or the other way of debugging this. The other way of debugging this is putting a breakpoint, right? I can put a breakpoint over here. Essentially, what a breakpoint is, right? And it's over on this line. You can on this kind of column, you can put a breakpoint anywhere you want, right? Essentially, what a breakpoint is a way for you to tell the program, hey, yo, bro, shut the fuck up, wait on this line. Pause on this line, right? Don't move, don't execute any code, including this line, please. Don't execute any of this code. Just stop the program over here. And it's very useful, because if I press play now, it's gonna execute, stop executing. This is gonna glow red, blue, colorblind, white, not white, yellow. This yellow arrow is gonna show up, right? And that means you're on this line, you've stopped on this line. So what you could do is you can inspect the variables. You can check this. Oh, it is 3. The count is 3. Crazy. And then you can move line by line. You can step into, step over, or step out. Step into. Okay, I'll explain these 4 later. We're just gonna press step over. We'll talk about this in a second. Just want to check this. 3, right? So 3. This is the count. It's count 3. So, like I said, you have to do plus 1. So you can see that it found the index of the comma is at 3, because 0, 1, 2, and 3, right? What I should do, the offset should not be count, should be count plus 1, because again, you should go after the comma. And so now this should give me count 2 should have the number, or the index number of, or the value of 0, 1, 2, 3, 4, 5, 6, 7, 8. It should have the value 8. So if I hover at count 2, it should give me the value 8. So if I click on step over, remember, if I hover over it now, you can see it says -8, 5, 8, 9, 9, 3, 4, 6, 0, because I am on this line. I haven't executed this line yet. This line of code hasn't run yet. And so I'm getting just a garbage value in memory. And that's why you initialize your variables to 0, because your variables have garbage values in memory, guys. I'm sorry. You step over, and now you execute this line. If I hover over this, look at that, it's 8. I'm smart. Who would have thought? That kind of rhymed a little bit. If I press play, I can check out the console. It's now, okay, so it now printed 120 and plus the 1 and a bunch of other things. Okay, so let's see why in the flying fuck did it print the comma, right? And the comma is this comma over here, right? It's printed the comma for this comma. But what I can do is just do count plus 1, right? And that's going to remove that comma. Crazy world. I know, we live in a crazy world, guys. It's unbelievable. It's just crazy. And you can see the comma is no longer there, right? The comma is gone, which is great. If you do plus 2, the space will go away. Wrong place. Sorry. This plus 2 over here, where we subster. We do plus 2 over here. Then the space is gonna be gonzo. You can see there's no space anymore, right? But we're not gonna do plus 2, because we're gonna trim the white space later. We're gonna also, don't worry, I got your back, Jack. So we just do plus 1 to ignore the comma. Okay, so now that we ignored the comma, and the comma has been ignored, because we don't like commas, what's next? Well, we kind of need to fix this, because we're not supposed to subser all this. Like, what the fuck is this, right? Let's see why this is happening. So again, if I put a breakpoint on this line, and I press play, right, I'll check the count, and the count number 2 is 8, right? Count 2 is 8. So this is what I'm saying. I am saying that I would like to start or cutting the string from the value 3 plus 1, which is 4. So 0, 1, 2, 3, 4. So I want to start cutting from here. This is what I'm saying. So I start from 4, right? Because 3 plus 1 is 4. Guys, basic fucking mathematics. If you can't do that, I can't help you, okay? God. Anyways, we're over here, right? What is the second argument of subster? It's not the index, right? It's not index 8. It's not 0, 1, 2, 3, 4, 5, 6, 7, 8. It is the count. As in, how many characters am I gonna cut from where I start? And I start over here. So I need to count 1, 2, 3, 4, 5, 6, 7, 8. That means both of them should have appeared. Do both of them should appear? That is the question. I could be wrong, guys. No, only one of them. Because you count this. So 1, 1, 2, 3, 4, 5, 6, 7, 8, right? And this is what I highlighted is what's being cut off because 8 characters, right? So you can see the space and the 1, 2, and then the comma, and the 1, 2, right? That's 8 characters. Okay? Right? So I'm basically saying, hey, start cutting from this index and cut 8 characters, which is wrong. This is not what I want. I want to tell it to start cutting from this index until the other comma, right? And I know that the other comma index is 8. So how do we solve this? How do we fix this? Well, it's just simple mathematics. How can I get how many characters that I need to cut, right? How do I do that? Well, I know that this is index 8, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? I know this is index 8. Cool? Lovely. We know this information we know. But I don't want 8. How many characters do I want to cut? I want to cut 1, 2, 3, 4. I want to cut 4. You could say divide by 2, but what if this is 4 characters? Just don't say stupid shit, okay, man? Divide by 2 doesn't work, okay? So we need to find some mathematical formula to kind of get this working. And that's really easy. So what I could do is figure out which index this is. This is index 3, right? So I could say 3, I want to cut 3 minus 8. What's 3 minus 8? 3 minus 8. It's 5. So I'd be like, hey, 1, 2, 3, 4, 5, right? So let's do that. I can do count 2 plus count minus 1. Crazy world. And if you notice now, if I restart my application, it will print 122, right? Or 121, right? So it printed the 120 and then 121 with the space. I don't give a fuck about the space. Space doesn't matter, right? So that's how you do that, right? I basically said count 2 is index 8. Count is index 3, right? So I want to cut from here to here. So if you subtract 8 from 3, you get 5. 5 minus 1, you ignore the comma, and so you just cut this part. Cool? Easy, guys. Easy. Basic mathematics. Come on. You got this. You know, I believe in you. I am in a mood today. A very weird mood. It's been an hour and 14 minutes. I might still have energy. We can keep going, guys. Come on. Alright, makes sense? Makes sense. Now, what about the space thing? What about the whole space thing? Well, I believe you can trim it. And I mean, we don't need to trim it. It doesn't matter, right? It literally doesn't matter. And so I can do this again. If I copy this code and I say count number 3, and then I do count 2 from count 3 to count 2, and then print v, and then so now we're gonna print 120, 121, 122. The 120, 121, and then 121. Okay, well, I forgot to I forgot to do something very important, which I don't know what the it's this. See, 120, 121, 122. Crazy. And then I can get the next character. Copy this, paste it over here, make this 4, make this 3, make this 4, make this 3, make this 3, right? I'm just incrementing numbers. Literally. That's all I'm doing. And the world we live in. And see, 120, 121, 122, 144, 120, 121, 122, 44. Right, 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 right. Cool. However, rather than me doing that, we could put this in a for loop. Crazy for loop. Oh no. Oh, I don't know. How did he do that? Crazy. Okay, let's put this in a for loop, guys. A for loop. So the question is, how many times do I need this for loop to run? Right? So for now, I'm just gonna say this for loop is gonna run 5 times, 6 times, because there's 1, 2, 3, 4, 5, 6 numbers, right? I'm just gonna hard code it now, but I need you to calm the fuck down. Okay? Really important you do that. You're gonna do it 6 times. Okay, so I'm gonna copy this code, paste it in here, and we're gonna think, how can we do this but in a loop? Well, it's a little bit easier to kind of, I can do. So let's look at the pattern, right? What's the difference between this block of code and this block of code? Well, there's the thing here, right? The thing with the thing with the thing, right? The offset. That's what I mean, guys. The offset. So I'm gonna do int offset equal to 0, and so I'm gonna do comma offset, right? Right, 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 right. So this is my offset. I got the offset. Offset plus 1, apparently. Cool. What's next? Well, instead of 0, it's the starting point. So I'm going to do int start equal to 0. And so this would be start, right? Plus 1, apparently. So, because, okay, notice this. Think about this for a second. We want to start cutting at 0. But here, we're saying count plus 1. We do need the count plus 1 or start plus 1. But we need to start at 0 because 0 plus 1 is 1. So what I can do is just put this at minus 1. Minus 1 plus 1 is 0, so we start at 0. Crazy, I know. I'm smart. Alright, so what's next? This part next. This is basically count 2. Fuck. How am I gonna do this? How am I gonna do this? It is the offset. Oh. Ooh, okay, so I can do this. Hold on. I believe I can do this. I think, not sure. I think this would be. So the count would be the count, which is the previous one, which is the same one as here. So this would be offset. This would be count. This is definitely gonna crash, but I'm gonna step this line by line and kind of figure out what's going on in the code, right? Alright, so I'm gonna put a breakpoint here. And then I'm gonna press play. Alright, so I'm gonna start I'm gonna go this line by line. So I'm gonna move on like this. I'm gonna check the count. Count is 3, which is good. This is offset 0. I'm gonna start cutting from start is minus 1. Okay, this is 3. 3 minus 0. This is bad because I am supposed to cut at offset. Okay, so this printed 1, 2. or 12, right? Because if we didn't do the 0 because there's -1 over here. So we are gonna have to say that offset is, I'm gonna remove the -1 over here. Okay, if I remove the -1 and I step, you can see it's 120, right? Or it's gonna print the 120 perfectly, right? So it prints 120, the first iteration. Let's look at the next loop iteration. What's the next loop iteration? What's the offset now? Well, offset's still 0, right? We need to fix the offset. So at the very end, when we are done, we say offset equal to count. And the reason for that is the offset is the count, right? This is how much we offseted by. As in, like, hey, you know, the count is 3, right? Where's my string? I moved here 1, 2, 3, sorry, 0, 1, 2, 3, right? And that's my offset. I moved by 3, right? But yeah, I think I'm gonna do count plus 1. Right, I'm just gonna make this offset. All right, so let's look at this step by step again in the code. Go, go, go. It should print 120, which it does. Next time. This is at index 8, which is correct. Remember, we did this at 8. Now let's see if this actually works. Start is still at -1. Okay, so now we need to change the start. Start would have to be count, right? Because that's where we want to start cutting. Right? We want to start cutting over there. So I can just say start count plus 1 again. Looks like the offset and start is the same thing, but whatever. Anyways, let's start this again one more time. So step, step, step. Ooh, oh, hello there. You crashed. Why would you crash, my friend? My friend, why would you crash? Okay, so this is 3. Start is, oh, -1. That's why. Okay, so start goes to 0. All right, let's try this again. Step, step, step. This should print 120, which it does, right? Start becomes 4. Offset becomes 4. All right, let's look at the next one. All right, this should be 8, which it is. So I'm gonna start cutting from index 4. Let's look at this. 0, 1, 2, 3, 4. Right? So I'm gonna start cutting from here. That's correct. Let's look at this. 8 minus 4 is 4. So from here, 0, 1, 2, 3, 4. So the next one's gonna be 120 plus the comma, which is a problem. So our code is not completely perfect, but hey, at least it kind of works, right? So this is gonna print 121 plus the comma. Hey, that didn't oh, okay, so it was, wait, what? So how did it not 8 plus 4? We're starting at 4. Okay, so we're starting at 4, meaning 0, 1, 2, 3, 4. And so we do 0, 1, 2, oh, count 4. So 1, 2, 3, 4. Okay. 1, 2, 3, 4. We don't start counting from 0 because this is the count. This is not an index. It's an index, you do 0, 1, 2, 3, right? If it's a count, you do 1, 2, 3, 4, right? That's okay, cool. So this so it kind of worked, yeah, it kind of worked. 120. All right, let's see if it prints the rest. Should print 122, right? And then 144. 144 and then 145. Right, 145 and then finally 146. 146, 156, right? And then that's our loop iteration. We're done. We did it 6 times, right? But here's the thing. So that's the code, right? It's easy, it's simple, and we don't need apparently 2 variables. So what I could do is just I could cut one of them and I can just call it offset. And so we just have offset, right? And this would be just offset. And this would work exactly the same way. So if I can try this again. Just to make this work faster, I'm just gonna put a breakpoint on here, right? And then I'm gonna press continue. And what happens when you press continue, if you put a breakpoint here, it's gonna skip this, or it's gonna execute all of this quickly and jump to the next breakpoint. So if I press continue, it's gonna jump over here and should have printed everything like 121. Right? So this is kind of faster way than stepping line by line, right? Okay. Now let me explain the stepping thing, because I didn't explain it and I'm gonna forget to explain it later on. So let me explain it right now. So the stepping thing goes something like this. Let me go to the main function, right? Because it's easier to explain there. Okay, let's say I put a breakpoint over to here, right? On this line, right? So I'm gonna press play. Now, there are three ways you can step in the code. There's step into, there's step over, and step out. So what is step into? Step into means I'm going to go inside this function. Remember, this line hasn't been executed. The draw function has not been executed yet. So if I step into it, means I go inside the draw. And you can see I jumped into draw. Right? Step out means I get out of this function. So this function will execute everything inside it, but I'm going to step out. You can see I skipped this function. If I step into skeleton, you're going to see step into, I go to the skeleton. Step out, the code will execute immediately and I step out, right? Okay. So that's step into. Step into means you go in the function. Step over is you literally step over the function. You don't go inside it, but the function will execute. So let's say you don't want to go inside the function, but you want it to execute, right? And you want to step over it. So the code will execute, will run, but you're stepping over it. And you can see we jumped over here. Step over again, I'm going to jump to display. I'm going to not go inside this. I'm just going to go to display immediately. So step over, I jump over here. I'm just going to go. If I press continue, because I'm in a loop, because this code is in a loop, which means it's going to run from top to bottom over and over and over. If I press continue, the code will go execute, 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 and then when it reaches this breakpoint, it's going to stop again. So continue, and see stop. Step over, step over, step over, continue, it goes back in here. Step over, 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 step over. So you can see the code executing, step over, right? Step over, line by line by line, by line, line by line, line on line, and line, 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 line by line, going line by line, one at a time. Line. Okay, I'm gonna stop. I'm sorry. Okay, right? So if I press continue, it's just gonna, instead of doing that, you're just gonna go back to the same line you were, because we're in a loop. If you weren't in a loop, that wouldn't happen. Okay, so that's step into. Step into, we go inside. Step out, you go outside. Step over, you step over the function. That's it. Those are the three ways of doing things, which is kind of cool. It's cool, it's nice, and if I remove the breakpoint and press play, the code will execute. My game's gonna run, it's gonna be beautiful, and we live in a beautiful house with the mirror. Okay, I'm gonna shut the fuck up now and go back to the code, right? So explain that. Now here's the thing. I hard coded this value 6. Where is it? Here, 6, which means it's gonna run 6 times, right? Which is great, but what if we don't have 6? What if we have 3? If we have 3, this application will crash. Okay, it did not crash. But still, it still ran 6 times, which is not great. Right? And I can prove it that it's ran 6 times. If I put a breakpoint here and I go here, it's gonna go here, and then it's gonna go here, and it's gonna go here, and then it's gonna go here, and you can see executed 6 times. That's not great, right? Because we don't need it to execute it 6 times. We only need it to execute it 3 times. Because see, 120, 121, 122, 120, 121, 122, which is not great because we only need it to execute 3 times. Because guys, we only have 3 numbers. I know, crazy, crazy, very crazy. All right, cool. Okay, that's not great. So how can we fix this? How do we know how many times this code should run? Well, this, in my humble opinion, this is what we could do. I could put a breakpoint over here. Aha, lovely. So when we encounter this character, we exit the loop. And we make this loop an infinite loop. There's 2 ways you can make an infinite loop. I can remove this condition, right? This is, remember, you create this section is where you create the variable. This section is the condition of how many times the loop should run. And this is what happens when you iterate or when you execute one iteration of the loop. Right? If I remove this condition, now I have an infinite loop because I'm going to create my variable, and then there's no condition for the loop to exit. So it's going to check this. It's always going to be true. So it's going to execute this forever and ever 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 and ever. Which means I really don't need the I, and I really don't need this. So basically, this is an infinite loop, right? This is one way to create an infinite loop. The other way of creating an infinite loop is using the while loop, which is a more common way to create an infinite loop. While true executes forever, because true is true, and because true is true, it is true that this is true. And so because it's true, it's going to execute forever because it's true. Because true is true, and because true is true, you get true, and true is true because it's true, because true is true, and it is true. Because it's true. Because true. Because true is true, and true is true. Because true is true, you get true, and I'm going to stop, I'm sorry. Okay, so now you have an infinite loop, and infinite loops are not good. However, what I could do, because it's true, what I could do is do the following. I'm gonna check if, and only if. Oh. Actually, I don't fucking know. Let's put a breakpoint and see if this actually works. 1 time, 2 time, 3 time, 4 time, 5 time, 6 time. Okay, 6 times. Ah, it did with the stupid. Okay. Well, in this case, I could do a comma and then press space, and I can do this. Okay, let's try this. 1, 2, 3, 4, 5, 6. Okay, and 6 is 156. And then if I go one more time, V is a semicolon. Oh, I know, guys, it's crazy. So what I can do now, I could say if V is equal to a semicolon, which I know, crazy world, madness. We live in anarchy, guys. Right. Alright, simple as that. So now we don't have an infinite loop. And we have to do our file like this. This has to be comma and then a semicolon here. We'll check the semicolon. Semicolon exists. It's gonna, well, exit. If semicolon doesn't exist, well, then we have an infinite loop, guys. As you will see in my demonstration over here. Numbers go by really quickly. I'm telling you, I'm in a mood. I'm sorry. I'm not myself today. Well, I am myself today if I'm crazy, and today I'm kind of crazy. And you can see I'm an infinite loop, right? Because there's no this, so. So technically, this is not the greatest way of doing it. Ah, fuck. Why did it not work? I put the thing, man. I put the thing. Why did it not work? I put the thing. What is the fuck is wrong with you, what is your problem? Are you like stupid? I speak Italiano. I'm trying to speak Italian. If anyone is Italian in the audience, I truly apologize for offending you. But you can make fun of me if you want. I don't give a fuck. I'm sorry, Mario. Luigi. Alright. Oh, it has the space. Alright, so this is a perfect time to kind of introduce you to the space. So what I can do, I can trim this. I can do dot trim. If there's no trim. Dot erase. No erase. Dot back. Dot begin. Dot compare. Dot trim. Okay, I lied to you. There's no trim in C++ because C++ is an old fucking language. So what I could do, that's what I could do. I could just do the space. Again, this is all bad stuff because there will be an issue at some point. You are gonna get a problem where someone is gonna do something. No, we're printing the V anyways. Right, someone is gonna do something, and it's gonna be very, very, very bad. Like even if you put a space, it's a disaster. If you forgot to do this, it's a disaster, right? It's a disaster all around. Or I could just not do this. But how would I know how to break? Or I could reserve this to a character. I could say 0, 0. If you see 00, then you know. I mean, that could work. If you see 00, then you. Well, I'll just gonna do this on my call. I'm just gonna do this. Right? Cool. Yeah. I'll just. It's fine, guys. I'm sure. I'm sure this is not gonna be an issue. I'm sure it'll be fine. I'm sure. You know, because I'm sure. Ensuring is very sure. Okay. Cool. This is fantastic. This is lovely. We got this so far. We parsed our data. Our data has been parsed. We said, hey, master. We've done all that. I can delete all this garbage. Alright, so I parsed my data. Now it's actually instead of printing it, well, add the data where it's supposed to be. So first I need to initialize my data. So at the very top here, I'm gonna do data. Or actually I have to do it over here. Because this is where I have my data length. Or I could just put it over here. Okay, so my data is gonna be new int with the data size of data.length. Right. So this is gonna be on the heap. Guys, remember, with the new keyword, this is gonna be on the heap. This is now a pointer on the heap. And we talked about the heap and we said how the heap is a very large amount of memory, or a very large section on the memory. It's called the heap. Heap is large. Because it's large. Large, right? The heap exists. Right? And so remember, because we did new, we have to delete this memory. This memory will not be deleted on its own, right? Because we reused the new keyword. So at some point I have to say delete data dot data. And because this is an array, I have to do delete like this, right? If it's just a regular pointer, you do this. If it's not a regular pointer, or this is an array, you do this, right? So just keep that in mind, right? So anyways, I'm initializing my data. I'm saying, hey, this is my array, and my array is this big. So I can verify this. I can, if I go here and I click on data, and you can see data is, well, fucked. I think it's fucked. I don't fucking, well, it says 6. Looks like it's good. That looks fine. It looks fine. I don't know if it's fine. It does look fine. And because it looks fine, I'm going to say it's fine. All right, cool. So now what I can do, instead of printing this on screen, what I can do, I can say data at index data dot data at index 0 equal to v, and v is the value. The value. What the fuck do I call this? I'm gonna call it v. He's a horrendous name. What do I call this? Index? No. Data? We already have data. I'll just call it data. Oh no, we have data. We can't call data again. What do I call? What do I call? Map index. Why not? And so I'm converting map index from a string to an integer, and I'm putting it in here. But I'm putting it in index 0. And index 0 is not great because this should increment, right? So what I have to do is int I equal to 0. I is over here, and then I do I plus plus, right? And there you go. So what happens here is the following. What the fuck is your problem, bro? A buffer overrun while writing data, while writable size is multiplied by, but 8 bytes might be written. Why the fuck would 8 bytes be written when I specifically said that it's an integer? And this returns an integer. What is your problem? Please explain yourself. If I cast this to an integer, will this be solved? No, it does not be solved. It does not be solved at all. Buffer overrun while writing to data.data. First of all, data.data is a horrendous fucking name. So this will be called map data. Right? Get that out of the way. Copy, paste, copy, paste, copy, paste, copy, paste, copy, copy. Yes, I'm sorry. I'm sometimes crazy. It's fine. It's fine. We're all there. Sometimes we're all crazy. It's okay. It's okay to be crazy. Are you gonna give me the error again? Or are you gonna be a little bitch? Looks like you're gonna be a little bitch, aren't you? Yes, you are. What's your issue? Data undeclared. Oh, date. I mean, I don't need to print any of these anymore. I mean, kind of want to print them, to be honest with you. To tell you the honest truth and the entire truth, like all of the truth, I kind of want to print this. Paste. Alright, is this gonna work? Oh, fuck, no, it did not work. It crashed. It crashed like it never fucking crashed in its entire life. But we did say it's 6. Ah, but you see, it will never be 6, because we have a semicolon. Yes, so we need to make sure that if it's a semicolon... Okay, so let me explain. Let me explain what the fuck happened. So, basically, it crashed because it said, hey, motherfucker, error's back. Okay, we'll deal with this error later. But essentially, it's not an error, it's a warning. But essentially, what happened here is if I press play and you go back in the stack, you can see look at index I. I is at 6, right? But we've said the entire array has 6 elements, and index 6 is 7th element because remember, 0, 1, a 2, a 3, a 4, a 5, a 6, a 7. Sorry, 6, right? The index 6 is the 7th element because 1, 2, 3, 4, 5, 6, 7. And we said that this entire array has only 6 elements, which means index 6 doesn't exist because 1, 2, 3, 4, 5, 6. We have 6 elements, which means I should never go to 6, it should go to 5. Right, so why is it going to 6? Well, it's going to 6 because remember, there's 1, 2, 3, 4, 5, 6, 7, or 0, 1, 2, 3, 4, 5, 6, right? The 6th element that doesn't exist, the index number 6, is the fucking empty space. It's semicolon, right? So what I need to do is check the semicolon, if it's a semicolon before I do this. Right? So if it's semicolon, I break. If it's not, I continue on with my entire existence, which is beautiful. I feel so fucking gay today. I don't know why. All right, is this gonna work? Well, give me a memory address. That's for sure. It's not 000 anymore. So this is a memory address, and I can inspect this memory address. Guys, I'm gonna show you magic that you've never fucking seen in your entire life. If I press here, if I go here, if I click here, debug, and then go to window, and then from the window. If I go in the window, and I click on memory 1. Let's go to memory 1, and I paste this index. Why the fuck wouldn't you work? Unavailable when debugging is running. Are you fucking stupid? Maybe I have to restart the application. Ah, you are fucking stupid. Okay, maybe if I have to do release. What? This is supposed to work in debug? What you say? You make no sense. Huh? Yeah, this is what we are release. What? Why is memory not working? Why is memory? Oh, unavailable when debug is running. I don't know. I think I have to put a breakpoint. Do I have to put a breakpoint? I do have to put a breakpoint. Let us put a breakpoint. Oh, look at that. Beautiful. Look at that. How this is working. Very nice. Oh, fuck me. I have to put a breakpoint here so I can see the memory address. Okay, so if I press continue, and you can see the memory address. And if I take this lovely memory address and I paste it over here, and I press enter, you can see the data. All the data. The entire data. Guys, I am really sorry. I don't know what the fuck is wrong with me. Alright, if I take this, if I look at this index, 7-8. So what is 7-8? 7-8 in hexadecimal. So if I grab my calculator, my lovely calculator, if I go to scientific, not programmer, and I type the number 7-8. If I go 7-8, you can see in decimal, it's 120. Guys, it's fucking 120. Look at that. Beautiful. Fucking genius. Look at this. Okay, so this is 4 bytes. We know an integer is 4 bytes. So this is the first byte. This is the second byte. this is the third byte, and this is the fourth byte, right? And because our 4-byte integer contain only the value 78, which is in hexadecimal, these values are in hexadecimal. Ladies and gentlemen, please focus with me over here. All right. Is there a way to convert it into decimal? I don't think so. I don't fucking know. But if you grab a calculator, a lovely calculator, a normal calculator, and you put the hexadecimal 78, you can see 120. All right. So what's next? What's next to 120? And you can see that this proves that arrays are next to each other, because this is 78, and I know this is fucking tiny, and I don't know how to make it any larger. But you can see that this is 78, right? And then next to it is 79, right? So let's see what 79 is. 79, right? 79 is 121. And what's in my map, right? 120, 121. Okay, so, okay, we're over here, 79. What's the next one? 7a. The next integer is 7a. So if I go here and I type 7a with my keyboard, it's 122, right? 122. Okay, so what's next to 7a? It's 90. You can see this is 90. Okay, so if I type a 90 over here, you can see it's 144, right? And next to 90 is 91. So if I do 91 is 145, which is 145. And 156 is 9c. So 9c is 156. So this is my array over here. This, all of this. This is what I just highlighted. It's my array. And it's next to each other. Guys, look. It's beautiful, isn't it? Yes. Yes, it is. Right? So we verified that this is, there, which is kind of cool. But, if you want a more readable, more human way of interpreting this, you can actually just fucking print it. Fucking idiot. Sorry. I'm aggressive today. I'm very, very weird today. I'm sorry, guys. I apologize. Truly. Truly from the bottom of my heart. If I had one. If I press play, you can see it's going to print all the values now. Well, if I remove the breakpoint, that is. So 120, 121, 122, 145, 140, 144, 145, 156, right? So it takes all that. Cool. So I filled my data structure. Lovely. Lovely work. Amazing work. Amazing. Amazing work. So I can just fucking delete all this garbage. I can put my try catch just in case something crashes. Right? So we got all this working. We have my file. We're loading our file, right? We're parsing our file in the most disgusting way humanly possible. But hey, we're doing it, guys. We are doing it because we're champions. We are the champions of the fucking world. Now, one thing I would like to do is at the very beginning, I want to specify a version number. So I'm gonna say version equal 1. And the reason I put a version number is because maybe later on down the line we change how this file looks, so we can know that this is version 1, this is version 2, and we can kind of try and merge the two files together. So maybe version 1, we decide not to have this, and we just do a 0. And version 1 has this, but version 2 has a 0, right? So we can say, hey, if the file is version 1, do this. If it's version 2, do that, right? So we can have that, which is kind of cool. So let's just add that real quick. Let's add that real quickly, very quickly, very. So int version, and we could put that at the very top, right? And this will be our version number. I go here and I say, hey, yo, bro, what's up? How you doing? How is life? F version to version, and we're gonna do that. And so if I put a breakpoint here, I should see that it's the version number. So this value should be 1. That's if I step into it. I can see version is 1, right? Which is kind of cool. Alright, so this small thing we want to do, and that's it. Other than that, this is pretty much done. Right, we're pretty much done. Alright, so I have my data, but it's right now stored over here, which is not great. I actually want to return this data, right? So what do I do? Well, what I could do is, return it, right? So the way I'm gonna return this, I'm gonna say, okay, this is gonna return a map data. right? And this is gonna be a pointer. And the reason this is gonna be a pointer is because I don't want to do a copy. If I don't do a pointer like this, if I just return this, it means that I'm gonna copy all this data and return it, except the pointer. Obviously, the pointer will not be copied. Let me explain. Let me just do it without a pointer and kind of explain it to you. So I'm gonna return a map data, and this instead of void, it's gonna return a map data. So I'm creating a map data over here, and then I'm gonna return a map data. So I'm gonna do here at the very end, return map data, right? I need to include map data. Okay. Right? Okay, so let me explain this. Where the fuck are we loading this? Is it in main? Is it in map? Is it in main? Oh yeah, it is in, no. Where is, oh, here it is, right? So in here, load is gonna return map data. So what I can do here, I can do map data md equal to this, right? And so I'm gonna put a breakpoint here. I'm gonna press play. I'm gonna hover over MD, right? And if you'll see that MD has all the data. You can see version 1 has the tile sheet name, has level 1, 16, 16, 5, 5, 5, and this is my array. And you can see the first number is 120, right? And I can expand it. It's only gonna show the 120, right? But this is my array, right? So what is happening right now? What am I doing? Well, essentially, literally, this is what's happening. I am, let me go over here. I am parsing my file, right? I'm creating an object called map data. I am parsing my file. I'm filling this object with data, like the version number, the tile width, height, everything, right? I'm filling map data, this object, with the data, and then I'm returning it. Okay? I return it. Where do I return it? I'm returning it over here. I'm returning it into MD. So map data load is going to return this in MD, right? Okay. What is happening? Well, literally what is happening is I am essentially copying the values, right? Whatever values I put in here, map data, I'm copying all these values and I'm pasting them in MD. Except for one thing that I'm not copying, the data, because this is a pointer. So the only thing I'm copying here is the memory address, not the actual numbers, not the 120, 121, 122, right? Because a pointer only holds a memory address. So I'm copying version from one location to the other, copying this from one location to the other, copying this one location to the other, copying, 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 and then I'm also copying the memory address, not the data, the memory address. So I'm doing a copy. How many copies? 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm doing 9 copies. This is fine. This is okay. Not the worst thing in the world, but why? There's no need to copy. I can just return a reference. Like, why copy? Just return a pointer, right? Return the object itself. So, what I could do, say I want to return a pointer, right? So returning a pointer would look something like this. I'd have to make this a pointer, which means I have to do new equal map data, right? And then this is a pointer, and now it's returning a pointer. Now I'm not doing any copying, right? But this has to be a pointer again. Oops, I closed something. This has to be a pointer, or has to receive a pointer, right? So now I'm just creating a new object on the heap. So if I use the new keyword, I need to remember to delete this at some point, and then I'm returning it. So this is also not great because now I have to remember to delete this. Not fantastic. Not great. This is not great. How can I do this? How can I make this better? Well, you can't. Well, you can. You can do one thing. Rather than creating the copy over, rather than creating the variable on the heap over here and then remembering to delete it, I can do something differently. I can say void. Okay. And I can request from the function input, I can say I want map data, pass it as a reference. So pass me map data as a reference, okay? And this is really cool. So I don't need to create an object in here anymore. I can just fill map data with whatever I need and just return map data. And this is void here. Void. Okay? And so now I don't do this like that, right? I don't create a pointer and say md equal this. All I do is say this. Map data md. Then I'm passing md as a reference. So what is happening here? I'm creating a variable on the stack called md. md is being passed as a reference. And because it's being passed as a reference, meaning I can modify this variable and I can change its properties. I can change its values. If it was passed as a const reference like this, I will not be able to do this, right? You can see there's an error. It says, hey, you cannot do equal. This is not allowed. Let's do. This is not allowed if it's const, right? However, if you just pass it as a reference, then you can modify the data. And remember, const reference means that you're protecting the variable from being written to or modified. If you just do this, then I can modify this. So if I modify map data, it means I am modifying, what the fuck is it? I'm modifying MD because the memory address of MD is the same thing as the memory address of map data. So if I'm modifying map data, I'm modifying MD because I'm passing by reference. If I remove the reference, different variables. Put the reference, same variable, right? So this is the nicest way to do it. This way, right? This way, I don't have to create another pointer and put it on the heap and remember to delete it, right? I don't have to deal with all that jazz. And I don't have to make a copy anymore because I created the object and I'm modifying it immediately. And this is perfect. This is awesome. This is the best way to do this, in my opinion, at least, right? However, there is one thing we have to remember again, is we have to remember to delete this, because this, like, there's no way around this. I'm creating the array later on. I'm allocating memory later on in the application lifecycle, right? So I do have to remember to delete this, but there's no way around this, right? There you go. So now if I go here and I put a breakpoint over here just to verify that this is working. If I hover over MD, there's no return anymore, right? So if I press play, hover over MD, you can see it has all my data, 1, 16, 16, 5, and another one, right? So there we go. I loaded my stuff and I took it out of this function. And just to show you this function again, it's void, it returns nothing. It takes the file name normally, and it takes this as a reference. If I go here, takes it as a reference, and I'm not creating anything here. Like, I'm not creating another map data. It just takes it as a reference. I'm just modifying it immediately, right? Modify, 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 right? And there's nothing to return. I'm not returning anything because this is a void. And all the data will be saved here and I can use it, which is fantastic, right? This is good. This is awesome. Okay. Okay, cool. So this is done. I'm loading my data from here. So now the last part is literally just get rid of this, right? I don't need this array anymore. I don't need it to be hard coded anymore because now it is in my file. It's in this file, right? So let's now work on doing that. Okay. Well, the first thing I need to do is I don't need this map loader over here. I can put this map loader inside the map itself, right? But I just put it here as a test. So I can just remove all this code, Control X, delete this. I can just go to the load function for my map over here. Okay, I'm gonna paste this code over here. I need the map loader and MD, both of these need to be created in here. So I don't know, I need to find a place. Where do I put them? Them here? I think so. Here, it's fine. Right? I need to include map loader. I need to include map data. Both private, so doesn't matter, really, right? Okay. So what's next? Well, map loader is gonna load my stuff, save it in MD, right? And now instead of hard coding what tile sheet I'm gonna load, this is pretty fucking cool. I can just do MD dot what was it called? Tile sheet, right? Where the fuck is tile sheet? I'm blind. Here we go. Tile sheet. Right? And let me just verify this actually works. I have no idea if this is gonna load correctly. Well, we'll see if it's gonna load correctly. Because a little bit different. In here I put assets, world, prison, that. And here I put the entire path. I think the entire path is fine. I think the entire path is okay. Oh, I need to remove the double quotes. Okay, there's no double quotes. I'm just gonna remove them. Okay. This is fine. What else? I don't know the size of my tile height. This is gonna be removed. Tile width. This is all being loaded. I don't need any of this. Right? So there's no tile height and width anymore. This is inside the map data, MD. So that's gonna be MD dot tile width, MD dot tile height, MD dot tile width, MD dot tile height, MD dot tile width, tile height, width and height. Right? We got that covered. What else are we saving in here? Width and height, scale. We have the scale. Right? I don't need to set the scale manually here anymore. I can do MD dot scale X, scale Y, right? Instead of this entire big like thing, I can just do MD scale X. This is a little bit shorter. It's the same thing, no difference. A little bit shorter. MD scale Y, right? A little bit nicer. What else am I saving? Scale, width, and height. Anything else? I am saving total tiles X. 3 and 2. So I can do that. There's 3 over here and then 2 rows. I can store these variables. Yeah, I'll do it later. I'm too lazy to do it right now, but just whatever, keep it like this. What is map width and map height? Why do I have map width? Oh, that is the map width and height. Okay. Where's tile X? Oh, I figured those out dynamically. Never mind. Okay. Oh, the thing I need to put is map width and map height. That's what I need to put. Okay. I need to put these. I'll do it later. Again, I'm a little bit too lazy to do it right now. I don't need this anymore. Map numbers. This is gone. Map, and this is also gone. This is gone. This will be, oh, because we need to specify this. This will have to be on the heap. This will have to be a pointer. This will have to be a pointer. Yeah, there's no way around this. This has to be a pointer because I don't know the size of my array until later on. Right, which is a problem. So, so notice again, I don't need these. These are all saved in my map file, so I don't need them. So I'll just do that, right? Okay. Now here's the thing you need to know: map size. What is map size? Okay, so this would be MD dot data length, which would be my map size, right? This would be map numbers. So map numbers would be MD dot data, right? This is my data over here, which I've loaded from the map. Okay, so map sprites. So the last thing is map sprites. Map sprites. We need to put it in here. So when we first start, map sprites equal to. This has to be loaded over here. After we load, map sprites equal to a new map sprites, or sorry, SF sprite, with, I'm just gonna hard code the number here, but this is what I have to do, right? And then md dot or not auto completing, md dot data length. Right? So I'm creating an array of array later on. I don't have to do SF. I don't think. Do I have to do SF? Right? Okay. Because here's the thing. Because map sprite is a pointer now, I have to dereference it whenever I have to do anything. Right? So I can't use the dot anymore. Ooh, can I? It's gonna crash. Let me. I don't actually no. Let me just make sure. If it crashes, I know it's fucked. It's a little bit fucked. Oh, it's actually perfect. Oh, it's actually worked perfectly. Never mind. I'm just an idiot. This part didn't work correctly because the numbers are slightly different. What are the numbers here? 120, 121, 122. Okay. 144, 145, 146. 146. Not 56. Okay. So delete this. Pointer. Right. And there you go, guys. Same exact thing, but now I'm loading it from a file. I'm no longer hard coding everything from here. This is fucking awesome. This is huge. This is massive. Because now, if I want to do anything, I can just add one more. 147. Press play. You will see a new. Oh, I need to. It crashed. Sorry. I need to select 7. This 7. Oh, it still crashes. Okay. So why did it crash? I told it 7. There are 7. What's the problem? What is... Oh, because I'm telling it only it's 3 by 2. These numbers have to be, okay, have to be 4 by 2. Oh, it's gonna crash again. I know. Where's this crashing? Let me just check where's this crashing. Like, this crashing in here. Map index is 130. What? Did I not? Okay, this, remember the whole simple mistake like this, it messes everything up. All right, so it's not gonna show, right? Because, well, I need to make this slightly different. I need to tell the map width is 4, but this is also gonna be a problem because there aren't 4. So I have to add 2 numbers. 48. I can't just add 1 number. And there you go. I have both of them, right? So the reason I had to add two numbers, not 1, is because I have to have 4 rows. So this is, in reality, this is how this is looking, right? This is how this looks, right? There's 4 number in a row. I can't just add 1 more number because you either have 3 or you either have 4, right? So this is just a small limitation. We'll fix it later. But anyways, we're doing everything from here, which is freaking awesome. So except this part has to be modified, obviously, and this should be put in the map. I'll put it now. But there you go. I mean, this is being loaded from the fucking map itself. If I want to, and I make this 1, this would look. It will change. This is fucking cool. This is the first tile. If I make this 7, that's 7. Right? Look. Fucking awesome, guys. Come on, this is pretty cool. Get excited. Alright, I'll hop over and excited. Alright, so this is complaining map sprites. Okay, so it's complaining that this is not initialized, so I'll just tell it it's null PTR. So it's happy. So we fix that. We need to put these on the map itself because I can't hard code these values. They have to be here. So we'll just put them here. Map width equal to 3. No spaces. Map height equal to 3. No spaces. Right. So this will be like one big line. So 3 and 2. And so in map file, and so this is where the versioning number, if we publish this game, right, and later on we added these, so I can increment this to 2, and now we can, in the code, we can figure out which one was 1 and which one is 2. So this is kind of good, but we didn't publish anything, so we don't need to do anything. Anyways, so map width and map height, we need to move this now and put it here. Would be 0. This would be 0, right? And the map loader, we have to tell it that those two exist. So now it's called map width, map height, map height. We're loading for both of these. And I'm pretty sure that's it. I mean, delete this, delete those two. Map width, it's md.map width, md.map height, md map width. Right, then if I press play, it crashes. What is map width? 3. Map height. Ooh, I said map width twice. Whoops. Do md dot. So I put this map width. It's supposed to be map height by mistake. So if I press play, there you go. It works perfectly. And now, right? There's no map width, map height. There's only thing these, right? Which I kind of need. I can't put them in the. They're being calculated dynamically. But anyways, if I make this 4, I can do 147, 148. Right? Press play. Crashes. Why crash? Where did this? What did I do? This 4. Another 4. Why you crash? What is it? What is crash? It crashed in the player. Why are we crashing in the player? Hold on. I mean, I know the player has nothing to do with anything. Let me just put a breakpoint. Oh, for fuck's sake. I forgot to change this value. It's supposed to be 8 now. Because 1, 2, 3, 4, 1, 2, 3, 4. Man, simple things like this, it's annoying because I don't know what. We need a better debugging thing. But there you go. Anyways, there you go. I made this 4, I made this 8. I wish I could remove the state length, but I can't. This is necessary. So this is what happens when you hardcode shit by hand. So, but anyways, so there you go, right? And so this is pretty cool, guys. This is fucking awesome. Now everything is on the map file. Make this back to 3 and 2 in this. Right, here's my map. I'm drawing my map. That's fucking cool. That's fucking awesome. It's great. Alright, I've been streaming for 2 hours and 14 minutes. But anyways, there you go. This is the code. Essentially, this is a struct, plain old data. I have a version number, the path, the name of the map, bunch of data about the map, right? Putting all the map data over here, right? And then parsing it. We explain this parsing, checking if the variable called this, and I specify, like, I give the correct value to the correct variable depending on the variable thing. Once that is done, I create a memory. I create an array on the heap, right? Need to remember to delete this at some point. In fact, delete. I'll do to do delete me later, right? So this is my to do, right? So I'm creating my array on the heap with how big the array is, which I get from the file, which is here, data length, right? And then I just parse everything, right? I parse it. I'm parsing this part, right? I'm taking this, putting it in an array, taking this, putting it in an array, taking this, putting it in an array. When it sees this, right? When it sees this, it's gonna exit. It's gonna break out of the infinite loop, and then we're just gonna close this, right? We're passing this by reference, which means there's no copy, which is awesome. And it's being loaded directly into MD or here map data, being directly loaded in here, which is awesome. And so now I just use this, since I'm filling this variable with all this data that I load from the map. I do the length, I do the tile sheet, and so on and so forth. My sprite, my map sprite, I had to make it a pointer because I can't specify the value here, like 6, right? And I can't hard code this value, and this value has to come from the map, which is it's this data length, right? And I can't specify it here because I haven't loaded it here. It has to be a pointer, right? And the pointer will be initialized later. After I load the map, I initialize the pointer to be equal to an array. So this is also has to be to do delete me later, right? Also have to delete this. Remember to delete this. Anytime you see new, you have to delete it. Really important. I'm not doing it now because I'm lazy shit. I mean, I could just do it here. I can just do delete. Right, I can do that. Kind of. I think that shouldn't be a problem. It should be good if I close it. Yeah, all good. Alright, cool. So this is freeing the memory. I mean, it doesn't matter. You don't really need it because when you close the application, the memory is freed anyways. But I'm putting it here because the destructor, when the destructor is called, it will free it just in case later on. And just, whatever. So that's done. I need to delete this tiles. Oh, it's fun. Delete tiles, right? Because it's new. Again, remember new. This is complaining, same fucking bullshit. I need to figure out how to fix this warning because it's really fucking annoying me. But anyways, right? We're done with all this, and I'm loading all my data from a map file. I'm not hard coding anything into the game anymore. And so next, we can build the map editor to actually write this file. Right now, we wrote this manually. We'll tell the editor to write this file, which is fucking cool. But there you go. Done. We've done this. Awesome. I mean, really awesome. And so when I load the map, rather than even hard coding this number here, I can just do a string file name. File name. Right? So this is file name. And now I can just put it in here when the main function over here. So if I want to load map number 2, I just load map number 2. I don't have to hard code it in the class itself. Just outside in the main function, which is again fucking awesome, guys. But anyways, I think I'm gonna close it on here tonight. I'm sorry, boy, for being super weird tonight. I'm just in a mood. I hope this helped. I hope you kind of understood what's going on. But yeah, we have a map. We're loading the map from the file. We're shooting bullets, we're walking, we're debugging. There's a bunch of debug stuff here and the player. This whole we're killing the thing guy, which is awesome. But yeah, next time or next lecture or next stream, I'm going to start building a map editor so I can place the tiles with my mouse, which is gonna be cool. That's gonna be entirely different project, so not in the game itself, which is pretty fucking cool. But there you go, guys. This is awesome, huh? All right, cool. I'm gonna end it here. Take care of yourselves. I'm gonna put the Discord group in the on the stream. If you'd like to join, be part of the community, that'd be fantastic. Don't forget to subscribe, hit the like button, that'd be awesome. If you have any questions, comment section is there. I always fucking forget to commit my code. Let me commit my code. Added a way to load a map from a file. Commit to dev. There you go. Pushing. Source code, all the source code is on GitHub. You can always check it out. Right? It's open for free. Anyone can check it out and get it. Yeah, guys. I hope you enjoyed the stream. I will see you guys next stream. Take care. Sayonara. Take care of yourself. Wear a seatbelt. You know. And yeah. See ya. Take care. Bye bye.